We thought Venus was a dead world. Too hot, too toxic, completely uninhabitable. But a new observation has detected something that shouldn't exist there at all. Astronomers are seeing signs of possible strange patterns and volcanic tunnels. Strange patterns on the surface. How these features formed raises a question no one ever expected to ask about Venus again. So let's find out what's really happening on Venus' surface. In 1989, NASA launched a spacecraft with a simple goal: map Venus in detail. That spacecraft was called Magellan. Magellan didn't carry a traditional camera, it carried radar. But why radar? Because Venus doesn't let you see it. Its clouds are permanent, opaque, hostile. No optical image from orbit can penetrate them. Radar waves, however, can pass through. And what it found shocked planetary scientists. Venus wasn't smooth, it wasn't static. It was covered in massive volcanic plains, colossal shield volcanoes. And something no one fully understood at the time: gigantic circular formations called Coronae. Hundreds of them, each one tens to hundreds of miles across. And they didn't look like impact craters. They looked like something pushed up from below. But what? That will leave you completely stunned. As they mapped Venus, scientists discovered strange, enormous structures scattered across the surface. Circular, mysterious, and unlike any craters they'd seen before. And they called them Coronae. Scientists suspected these structures were created by plumes of hot material rising from deep inside the planet, similar to mantle plumes beneath Hawaii. But there was a problem. Venus doesn't have Earth-style plate tectonics. On Earth, tectonic plates move, collide, and recycle the crust. That motion releases heat gradually. Venus appears to lack that system. So how does it cool itself? For years, no one had a clear answer. Until scientists at NASA Jet Propulsion Laboratory revisited Magellan's data using modern computational modeling. They combined topography data with gravity measurements, looking for hidden signatures beneath the surface. And what they discovered was stunning. Out of 75 large coronae analyzed, more than 50 showed evidence consistent with active mantle upwelling, meaning hot material may still be rising beneath the crust. Not millions of years ago, possibly now. Venus might not be geologically dead, it might be simmering. Earth cools itself through plate tectonics. Venus might cool itself through pulses. Instead of plates sliding and subducting, Venus may trap heat beneath its rigid crust until pressure builds high enough to rupture the surface. Think of it like a pot with the lid sealed shut. Eventually, something gives. Coronae could be those pressure release points. The crust bulges upward, fractures radiate outward. Molten rock intrudes into the lithosphere. Then collapse follows. A violent geological exhale. And if these processes are still active today, Venus isn't frozen in time. It's evolving. Then came another mystery in the radar images. Long, winding channels, stretching hundreds of miles across volcanic plains. Some of them narrowed and vanished. Others showed circular pits, like skylights punched through a ceiling. On Earth, this pattern is unmistakable. Lava tubes. When lava flows, its outer layer cools and hardens. Inside, molten rock continues to move. When the eruption ends and the lava drains out, a hollow tunnel remains. On Earth, Hawaii's Kazumura Cave is the largest known lava tube, stretching over 40 miles long. But Venus is different. Its gravity is slightly weaker. Its eruptions may have been more massive. Its volcanic plains are enormous. Radar analysis suggests at least one potential lava tube on Venus could be nearly a kilometer wide and hundreds of meters deep. To put that in perspective, You could fit multiple skyscrapers inside, entire city blocks, underground, on a planet already dominated by fire. These aren't tiny caves. They're planetary arteries carved by rivers of molten rock. So, why this changes everything? If Venus has active mantle plumes, if it has ongoing volcanic activity, if it still forms lava tubes, then it is not a relic of the past, it is dynamic. And that matters for three enormous reasons. 1. Understanding Earth's future. Venus likely once had oceans. Some models suggest it may have been habitable billions of years ago. Then something triggered a runaway greenhouse effect. Oceans evaporated. Carbon dioxide accumulated. Heat spiraled out of control. Studying Venus helps scientists understand climate tipping points. It's not just another planet, it's a warning. 2. Understanding planetary evolution. Earth and Venus are nearly identical in size and composition, but their destinies diverge dramatically. Why? If Venus is still geologically active without plate tectonics, that forces scientists to rethink how rocky planets evolve. It expands our models for exoplanets orbiting other stars. It changes what we consider Earth-like. 3. Future exploration. NASA is preparing to return. The upcoming Veritas mission will map Venus in unprecedented detail. Higher resolution radar, better gravity measurements, sharper topography. If there are fresh lava flows, if coronae are still deforming, if new vents are opening, Veritas could catch Venus in the act. Imagine detecting surface changes between missions. Proof that an alien world is actively reshaping itself in real time. Here's where things get even more intriguing. On the Moon and Mars, lava tubes are considered potential habitats for future astronauts, shielding from radiation and temperature extremes. On Venus, the surface is hellish. But underground? If lava tubes exist, their interiors might be structurally stable. Not habitable by humans, temperatures are still extreme, but scientifically priceless. They could preserve geological history, trapped gases, clues to ancient eruptions, maybe even insight into whether Venus once had water. They are time capsules beneath a furnace. For years, Venus was the forgotten planet. Mars got the rovers, Jupiter got the glamour, Saturn got the rings. Venus was dismissed as hostile and uninteresting. But now, it may be one of the most geologically fascinating worlds in the solar system. A planet that doesn't recycle its crust gently, but may periodically resurface itself in catastrophic episodes. A world where the ground may still flex, where heat still rises, where massive underground tunnels stretch beneath volcanic plains. Venus isn't boring, it's unpredictable. Look up before sunrise. You might see a bright object near the horizon. That's Venus. For thousands of years, civilizations called it the morning star. They had no idea it was a pressure cooker of carbon dioxide. They didn't know it might have continent-sized lava flows. They couldn't imagine kilometer-wide underground tunnels carved by molten rock. But now we do, and the more we study it, the stranger it becomes. Venus was supposed to be geologically finished. Instead, it may be breathing. Not like Earth, not gently, but in slow, powerful pulses of heat from its interior. Coronae may mark where the planet pushes outward. Lava tubes may trace the paths of ancient fire. And future missions may confirm that beneath those toxic clouds, Venus is still changing, still cracking, still flowing, still alive. And if a planet so hostile, so extreme, so violently transformed can still be active billions of years later, then our solar system is far less predictable than we thought. Venus isn't just Earth's twin, it's Earth's alternate timeline. A world that shows us what happens when planetary systems tip too far. And somewhere beneath its clouds, under miles of volcanic plains and collapsed lava roofs, a tunnel may still wait in darkness. Silent, massive, carved by rivers of fire. Proof that even a world that looks dead can refuse to stay that way. So if you liked this dive into Venus, smash that like button, share it with your friends, and subscribe for more out-of-this-world science. See you in the next adventure.